Okay, it's Mark, and it's a brand new show. And tonight, let's see, what is it? It's October 21st, 2015. In tonight's show, I want to talk about making armatures in a new way using Tinkercad, which is it's a free program that you can use on the internet. And before I show you that, I want to show you guys how they would make armatures for clay animation. And as you can see, brass tubing is a very common way to make armatures for any kind of character, actually. Anything where a part would be removable, or making feet that you can tie down, or making chest areas or hip areas that you can grab, or create a surface for clay to stick to. And so this here is a very old Will Vinton Studios armatures. This is one that probably maybe John Ashley, or maybe Chuck Duke, or somebody, not really sure who. Could have been anybody. Jamie Haggerty. So what they would do is they would take these brass tubes and they would essentially cut them with tools, like a hacksaw or a Dremel wheel or some other tool, to create a length. So for example, here we have something that's maybe an inch wide or so, and they would calculate, they would sketch the character on paper, they would measure the character, they'd rescale it on a Xerox machine or draw it to the proper scale, make measurements, and then from there you could tell how wide an armature has to be, what kind of surface area you need. Maybe you don't want to have a large chest piece because maybe this character is really skinny, and you want to have something thin here. Or maybe you have a fat character where you want to have a big ball of something here to take up the space, to add your clay, something that's lightweight. So they would use things like wood or balsa wood or styrofoam, or whatever they could get their hands on that was available at the time. And so some of the materials that they had were, you can still get them today. You can still build armatures this way. In fact, it's a great way to build armatures. Like if you have this a setup for cutting brass, for example, you have hacksaws already, you have Dremel wheel, cutoff wheels, and you have a drill press, and you have hammers, and you have a propane torch and solder, and all that kind of stuff. It's there's nothing wrong with this at all. So Ron is asking, is this for a flying rig? And yeah, it seems like it is, actually. So you can put a brass piece in here and attach and detach it from behind the puppet, which I believe that's what they probably use this for. And it could also be, if that puppet was really super heavy or sagging, they might just add that for the ability to hold that puppet up if it gives them problems. So what else can I say about this? There's basically different ways to do this. They used to use a low temperature solder to adhere lead wire into the holes, into these holes here, which are actually smaller brass tubes that fit into larger brass tubes for replacement purposes. And so the tubes here are like bones, so that there's no flex in this piece here, and there is here obviously where the wire is exposed. So that gives the animator an ability to control where this leg will bend. And if you have clay, which is what they had over this armature, some of the things they would think about are making these the right distance between these tubes to make sure that the wire doesn't get bent in too tight of an angle, which makes the wire weak. And it's time consuming. It's really time consuming to make these parts. So for every single puppet that had this configuration, they would have to cut 1, 2, 3 parts for this T section. They'd have to drill holes and solder on at least 3 little nuts and put in some set screws. And how long do you guys think it would take to make an armature like this? This would probably take half a day if you were really fast and you were experienced and you had everything figured out ahead of time, right? So maybe half a day, I would say. But the thing about this is that there were parts on here like these feet that are repeatedly needed for puppets, and they could reuse these parts because of the replacement functionality that they built into it. So let's say the ankle would break here. They could loosen the little set screws in the back, which looks like this here. Okay, so they have a hole drilled through here, and then this little set screw goes right through this hole, into this brass piece, and presses against the brass piece that you slide in there, right? And so that means that it sticks really well because of the tension. And when they remove it, they could reuse this part. But, still, you would have to build a lot of these by hand. And so anyway, nowadays, there are ways that you out there, anybody who wants to do this, can design a foot, and without having to solder things or rebuild things over and over again, you can literally 3D print these out. And armature building is definitely an art, but to me, the exterior of a puppet is what is more important than the aesthetics of an armature, because you don't see it. It's purely functional, and it can be beautiful on its own, and it's a great thing to learn about and learn the ins and outs of. But what we're going to do is we're going to talk about a new program called Tinkercad, and this is a free program. You can go to tinkercad.com and sign up for an account, and you can start building stuff. And here is something that I actually started to work on, and I'm gonna, once I actually start building things on this web page properly, because this is my first go at it, I'm gonna make these available for anybody to download for printing purposes. So that means also you can look at the design, you can measure it, you can see if you like the way it looks, see if it would work with your own puppet designs, and then you can download and then edit this on Tinkercad yourself to fit your own designs. So it's basically open source armature making for anybody. And the materials you can print this out in are in anything from metal to plastics, all kinds of stuff. So Rana's asking, Mac or Windows? Well, I don't know if it will work on a Mac. It works on my browser. It's actually in Firefox. It's browser based, and it's cloud based. So essentially, you can have people who are on a team of armature designers. They can come in here. You have different accounts, and then you can share your accounts, and then you can all work on your designs. So here is a foot, and I'm calling it the world's most versatile stop-motion puppet armature foot. And this was actually, a learning process for me. And so I screwed up, and there's some stuff in here, like these holes, which I filled up, but they still have outlines where I filled holes from mistakes. But I'm gonna redesign this foot. What it has are 3 options. The first option is like what we just saw, and that is to, let me zoom in on the foot here. Now, the armature foot that Wolverine used most often were screwed down from above. And hey everybody, Dean is here, Jamie Cleary, welcome to the show. And also welcome Sten43 and Claymara too. So anyways, Getting back to the armature. The feet were essentially notched, right? So we have brass, which would be fairly thick because they don't want it to flex. And sticky bones, you know, we could kind of talk about that here also, Jamie. That's a good topic. So the feet here, you notice, have a little notch, right? So you can put a screw from above. And so what I've done is I've created this foot, and it's got a big notch. And so you can essentially put a screw into the foot from above in the tip here to hold it down, to tie it down. I've also got the ability to add a tie down of your own sort of devices. So like if you go to Ace Hardware and you get you just need three things, right? You need a nut, a bolt, and a wing nut. And this hole is designed for that. So you put your nut in the top of the foot, you add a couple of drops of epoxy, and it's not going to twist out because it's the same shape, right? So that's the other option. So we have a foot that allows for tie downs, for a screw through a wooden set floor, and underneath I have also 3 holes. And like I said, I need to remake this foot. This is going to be sort of my what I go to as reference. But we have 3 holes that are 5 millimeters in diameter here. And from here, you can put a drop of epoxy into each hole. And you can either put in, if you wanted to, some 5 millimeter round rods made from steel. Or you can put in magnets. So you have magnets, you have tie downs, and you also have the ability to screw your foot down. And I am going to share the file. Once I actually finish this, I'm going to make it available for anybody who wants to download it, alter it to your own specifications, or just to use for reference. What I've also got is 2 holes that go in the tip, which will accept some 1/16 inch gauge aluminum wire. So that will mean that if you have a toe, for example, that flexes or is longer than your the dimensions here are 30 millimeters long by 18, and that's not too big, not too small, but that gives you the ability to either put in wire here. And I also plan to make a let's see, on Control Z. This is not going to be the final design, but you see how we have the 2 holes in the tip, and that means you can stretch the 2 wires on each side and have perhaps a toe, and then I could make different toes. I was thinking, so a toe that you can put a screw in like this piece, or a tie down, or a piece of steel. But I think it's going to be hard to animate using magnets, a walk like that, so I might not do that. But it's a very simple design, and Tinkercad has so many awesome Stan is asking, where is the show? Well, hopefully you might have to hit refresh. Maybe it's not loading for him. But check this out. Now there's also other things which I find really awesome about this, because you can actually print out threaded holes. You can print out threaded rods. And the way you do it is you just drag one of these custom, this is actually a community-based shape, okay? Let me see if I can zoom in. And somebody designed this in such a way, and it's really cool, because if you have, for example, certain hex screws that you like to use, that you have a whole batch of in your garage or something, and you measure the threads and you measure everything properly like an engineer would, you can actually duplicate all those dimensions using these little sliders. So we can make the diameter bigger or smaller. We can change the pitch. We can add more segments, which is a little weird. The number of rotations. So let's make like 12. You know, we can make the tip scale, whatever. Again, tip segments, thread scale. You know, these are all things which, you know, if you really want to tweak it to be exact, you could. And Ron Cole is asking, would the metal be strong enough? Well, you know, it depends on what you do and what you build. For example, this here, not really liking the diameter, but let's see. But I'm going to show you guys some of the basics here now. Let's say, for example, we want to make a very simple foot with that we can put a tie down inside of. Let's see here, shape generators. Oh, Jamie was mentioning. Jamie mentioned sticky bones, right? This thing has something that is similar to sticky bones, which maybe I should actually just briefly mention that now before I get into more complicated stuff. TinkerPlay is oops, where did we go there? Darn it. Yeah, TinkerPlay on here is a free sort of thing that you can actually build all that. The same stuff that you can build in Sticky Bones. Three-dimensionally, you could actually you can build it here in Tinkercad. And here's a joint. Now, I don't know how well these would hold up under stress, and I don't know what the best printing material would be for this, but you can actually build your own stuff right here by printing these parts out. So here's, for example, a ball. Here's a joint. They have feet as well. I still think my foot is cooler, but you know, I'm thinking from a clay animation perspective where, you know, I don't know if these joints would hold up very well to the stresses of stop motion animation where you have to put wires. You know, a wire wouldn't hold up to anything in here. You'd have to epoxy it, and any sort of heavy clay material on these joints, I believe, would fail pretty quickly, no matter how you print these out. But I did want to mention this, and I have not talked much about sticky bones yet. I have heard about them, but yeah, if you're interested in you know, something that's similar and open source where you can actually redesign these parts. You know, we can make these bigger if we wanted to, in length, you know, and of course this would change everything, right? So it's probably not a good idea to do that, but I know there's a way to. Is it this? Yeah, you can actually scale these. If I hold Shift, everything can be scaled up properly, and if you scale all these parts up or down at the appropriate percentage points, in theory you could actually make all these things work. So you can make that ball fit right in that socket, and let's see here. And this would probably require a lot of trial and error, or at least math. So if you started out, for example, and you wanted to scale up these joints and make them work together. Oops, let's see what we can do here. So we know that these balls and these joints probably work properly together. You could measure, you know, you could say, well, this is 32.85 millimeters. And this one here is 41.85 millimeters. You can technically, you know, add 10% to both of those. You know, multiply it by 10% or something, and you know, scale it up, whatever your calculations are. And they should technically work, but like I say, if you scale it up and the parts are thicker, does that affect, you know, the you know, how they'll work? Because these parts would be stronger, and I don't know. But you could build an entire puppet that way, and it would probably work, you know, fairly good, right? Yeah, you could. Dean is saying you can build a man-sized armature. Sorry for Sten. Sten can't view the show for some reason. That's too bad. But yeah, and Ron says, I keep getting emails from Shapeways about their metal pendants and jewelry and stuff. But so, he says, I had been wondering about armature parts and small props. I really need to find out the strength limits. Yeah, there's definitely limits. Definitely. Oh. Okay, 1 second, guys. My son is knocking on the door. 1 second. All right. My son hurt his foot, he said, but I think he just wants me to talk to him. All right. So, anyways, my son. That's fine, little boy. Go ahead. So, sorry about that. So, getting back to what I was talking about. So we've got lots of different options. You could make your armature parts, you know, from joints on here for free. There's unibodies, there's connectors, connectors by themselves, and I believe there's actually some other parts which aren't on here yet because they seem to add more things over time as I've tinkered with this. Pardon the pun. And but let me show you guys something really cool. Okay, so this is the community-based parts. Let me see now. Geometric. Okay. So you can start with the simple box and plop it down anywhere. And what's cool is, you know, you hover your mouse over one of these dots, right? And you've also got this grid system here as well. So you can see the size is 20 by 20 millimeters. And you simply just drag it. You know, you can drag it however you want. Now, you also have a grid setting, so you can have it snap to the grid, for example, every, I think it's 2 millimeters here. So, or is it, let me see, yeah. So whatever you start with, you know, you can, or you can have it snap every 5 millimeters. So if it's easier for you, because if you have their little snap grid system here on 0.1 and you start moving it around, you know, you get these, you can basically make it any size you want down to you know, like 1/10 of a millimeter. So I'm gonna undo all that and snap to, let's say, 1 millimeter. Not that I know of. Ron, you're asking if there's an imperial measurement system. Maybe there is. Maybe there is, but I haven't discovered it yet. But I think the reason why they might not have that is because most printers will, when you print, have a bounding box, which is in millimeters, depending on whatever 3D printer you have. It's mostly almost always in millimeters. So you can either use a millimeter to inch chart on the internet. Just type on Google like to inch, and I found charts, and that's what I used. I found a chart. I forget what it was called, but you just got to convert it. And there's also, I think, on Google itself, you can just type in the number of millimeters, or just use a millimeter gauge if you have one as well. So yeah, you can edit this grid. You press W, and you can move your grid to different areas of your part. So here I'm going to move it to the top. I'm going to move it to the sides. So there's little shortcuts like this. And what this does is it allows you to add other parts on top of an object. Alright, so I'm going to press W and click off to the side. So I've added a part. Now if I want to join these two pieces, I select both. And I click on group. And now we have a new solid part. Completely simple, right? And I can move this around. They're stuck, right? So you sort of welded these things virtually together. Jamie is asking about, is this better than SketchUp? I'm not really sure. I mean, what I can tell you about this is it's super simple. Super simple. Alright, so anyway, let's just say this is going to be a torso for our puppet, right? Actually, you know what? Let's do something even simpler. Let's actually make a foot, a really simple foot. And we're going to make this accept a threaded rod. I'm not going to even worry about too much of these things over here. I'm going to try to scale it down a little bit. Alright, so even if you don't know all the terminology, you don't know what a pitch is, a diameter, just, you know, play around with it until it looks right. And this is what I like about this program, is you can just go by what looks right. And completely screw up, you know, and erase what you've done. And so we're going to make this little screw. We're going to put a cylinder on top. Going to rescale it. Let's look at this here. Going to make a really ugly screw. I'm going to group these together. Now it's one piece. Okay. And then I'm going to take this part and just using my eye here, see if I can center this up. Alright. So what I'm doing is I'm just moving this part into the other part, making sure it's lined up. And then I'm going to click this, which is whole. And then I'm going to group these together. And that part will disappear. And I have a screw. Okay, so now I'm going to take this, I'm going to move it over our foot. And I'm going to say, let's just pretend that we're going to have an ankle in the back of this block. So I'm going to scale it up to make sure we have enough room for that. Alright. I'm going to move this down a little bit. And I'm going to click, I'm going to hold down Alt first and duplicate that. And this one here, I'm going to make a hole in my foot. I'm going to click this little hole thing here and group these together. And that screw will disappear, but it leaves a threaded hole right in the center. And that threaded hole will correspond to our screw. So without having to worry about you know, how many threads per inch or anything, There's no tap and die sets here. There's nothing like that. I basically tap and died, you know, this hole using the screw itself. And now I can print out, we can print out this screw in this block, and guess what'll happen, right? It'll actually screw into it. Precisely, or at least as precisely as it's printed out. So for the back part of the foot, we could make a, let's say, I'm going to press W and click on the top here to change our grid so the grid sits on top. I'm going to add a cylinder. And I'm going to hold shift, and I'm not going to do it that. I'm going to hold shift. Oops. Alright, that was dumb. And scale this to the correct size of our piece. By the way, if you want to know the size, you just hover over. You can hover over this part, the red piece. And it's lying to me here. So we see it's 15 millimeters by 40 millimeters. So we'll make the cylinder 15 millimeters. I'm going to hold shift to make sure that it scales properly. So we had the same width as our red piece. We can check to make sure it's on there properly. Hold our little white blob there and until it looks about right. And give our group these together to make basically a foot, one solid foot. And so this would be where we can make a hole, right? Another hole using a cylinder. Let's say we have some, I don't know, we're going to use a 5 millimeter diameter wire there, for example. And that's going to be our armature wire, and then we want it to go inside this foot. So we need to make a hole for it. So we're just going to hit the hole button here. Select them, group them. And so that wire disappears and we have a hole. So we have a tie down hole and a hole for wire right there. As simple as that, right? So James Cleary is saying, but normally you would want to use a standard thread, right? Or import a screw model from a manufacturer. Yeah, you could actually. You could do that if you have a preference. If you're a fan of, you know, like the Small Parts Company or anybody who's, you know, producing stuff like that, it's, yeah. And you could, like I say, if you use these, where was it now? Geometric. Go down to, yeah, it has so much stuff that sometimes it's hard to remember where they're at. Community parts here. So yeah, you plop your part in here, and if you have a certain, you know, pitch and a certain number of threads and all that kind of stuff, you just dial it in this way. Or you know, they've got on their site. Let's do this. You could actually search for screws on here and see what pops up. And a lot of this stuff might be, let's see, maybe they don't have any. All designs. I don't know why only mine came up. And how did it know I was doing that? That's the other thing. I didn't tag it or anything. What can we look up on here? Maybe more specific, machine screws. Let's click gallery and see if there's anything on here. But you can see what other people have uploaded. Maybe I need to search somehow on here. Here we go. Okay. Yeah, so there's many types, it looks like. A lot of people have uploaded on here. It looks like what they've got is Metric sized hex head cap screws, perhaps. Metric 10, 12, 16, 24. That's pretty nice. So yeah, you actually probably could find specifically what you're looking for on here. Somebody's done it for sure. Here's another type, and you could download these and alter them to for your purposes. So Jamie says McMaster-Carr has 3D files for screws they sell. Awesome. And yeah, so since Jamie's mentioning that, one of the things I learned is that you can actually load up those files in here. You can design, you can download your design, you can upload to different places. But yeah, see, I don't want to make a new project. Well, I suppose I could because I did save mine already. So let me save this, and then once it's saved, let's click on new design. So we can go to import on the sidebar here. So I didn't really need to close that other one, I guess. But you can actually browse your computer for the proper printable files. So maybe we can, let's try to do that now. Let's go to like McMaster-Carr. Or this is pretty awesome, isn't it? That you can do that. I didn't even realize you could do that. So Jamie, do you by chance know where we could look for that? Maybe 3D screw. Oh, 3D prototype printer. Let's say machine screws. Drive style. Specification, specs, bookmarks, order. Alright, let me do something here. I'm gonna have to grab Google real quick. So he's saying click on the pictures, okay. Awesome. 1/8 inch. So it's pretty neat though. At least they have they've got some of the specs on here already, like yeah, they're probably probably in some hard to find area. Let me do something. 3 printable file screws. Here we go. Awesome. All right, it's loading up. I found out. Found the links. So there's an instructables on how to do that. Check that out. Oops. So it says here, first thing you do is find your parts. Note the symbol of what you want. It says here, for technical drawings and 3D models, click on a part number. And it says this is the one next to the part number you want, product detail. First point your browser to McMasterCarr.com, which we'll do now. I'll click on screws and bolts, because these are extremely common things to use for armatures. Let's Click on this one. Oops. Of course, everything pops up for me here. All right. So here's a part number. Let's just, I hope that's the part number. Product detail. Oh, check that out. Let's see. So you can download it as several files, several file types, but I don't know if you can import these. 3D Step, 3D SolidWorks, 3D SAT, PDF. Well, you may not be able to. You may not be able to. But the cool part is at least they have a diagram here showing you the number of threads and all of that. 3D SolidWorks, yeah. Let's see what that does here. Let's try to save one. Let's try to load one up. I'm gonna save this as, let's just say desktop here. I just call it solid. And then let's go back to check that out. It's another website. Let's try a file. Or wait, let's browse it. And solid. And open. Let's see if that works. Oh, okay. So it must be a .stl or a .svg format. So, do they have that? Is it possible there's two terms for SVG and STL, huh? What's this? Where do they say that saves as? And so it's literally a .sat. There's no... Yeah, so it won't work for this, but I imagine for other 3D programs you can use it. And iSpec method says step is a good multi-software format. That would be so cool if you could do that though in this in Tinkercad. That's too bad. But anyway, so let me see. Where's my old design now? Okay, I don't know. I hope I didn't lose it forever. I'm sure I can find it. Let's see. File URL. File, no. Let's see, it showed geometric shapes. Yeah, I may have lost my work there, but that's okay because it was just a test design anyway. But this is it, and you know there's so many different shapes you can find on here from you know, users that have made every conceivable thing you could imagine. And some of these shapes are kind of neat, like this weave curve. This is something you could actually use, which has a bit of texture for, you know, a chest piece, a solid chest piece, perhaps. What else do they have on here? Let's look. Here's a bent pipe, a hollow bent pipe. Maybe for shoulders, for sticking wire in there. That's possible. They have, let's see. I believe they even have like gears on here someplace. So if you're making like a breathing mechanism with gears, you know, that's possible to use too. or some sort of go motion design where you need to you know, use a stepper motor of some sort and make like a coupling between the two. So yeah, so many options, and like I say, it's so easy to use, and they've got tutorials as well. They've got videos, and let's see, this one here is only almost 3 minutes long. Let's watch this one and just see what it says.
Design tool that runs in your browser. This tutorial video will teach you the basics of using Tinkercad. What makes Tinkercad unique is the focus on constant learning. You can create something from scratch, follow a quest that teaches you new skills, or find a thing someone else has designed that you want to study and perhaps modify. To start a new design, click the Design a New Thing button. This is the editor. The arrows on the left are part of the view controls. On the right, there are basic shapes you can use for your design. You can create things by dragging shapes to the workplane. To move the view to another angle, click the arrow buttons. You can also press and hold the right mouse button down while moving the mouse. Zoom the view by pressing the plus and minus buttons, or by using the mouse scroll wheel. You can freely move shapes along the workplane. Use the top handle to change the height of the shape, and use the corner handles to change its size along the workplane. Use the arrows to rotate the shape. Move the shape up and down by using the arrow handle on top of the shape. If you select several shapes, you can modify them simultaneously. Select multiple shapes with box select, or by holding the Shift key down and clicking on the shapes you want to select. If you press and hold the Shift button while scaling, Tinkercad will resize the shape equally in all directions. Use copy and paste to duplicate shapes. You can use any shape to make holes. Just select the shape and press the Hole button in the toolbar. It's a good idea to group related shapes together to make further editing easier. You can always ungroup shapes later. There it is! When you're done with designing, click Save and Close. After that, you can give a name to your new thing. Your design is now ready to be 3D printed or shared with friends. Design a new thing of your own and have a great time learning at tinkercad.com.
All right, so you know, it's not really a tutorial, but there are really good ones actually on there. Now, is it easier to machine stuff in steel? Now you can get these things printed out in, I believe, steel at shapeways.com. You can actually get them printed in brass for sure. I know, platinum, gold, you know, steel, brass, or bronze. So yeah, you can actually, you know, have that done, but it's so expensive to do. So definitely, I don't think it's very economical yet. But one thing I want to show you guys really quick that is cool about this is that one of the things that is really hard to do, and you know, if you're trying to machine parts, especially holes, is negative shapes. You know, so for example, here's a hole which I'm going to make. I don't care if it's centered or anything like that. Let's just try to get it kind of close. Let's just say there. I'm going to group these to get rid of that. Now if you make a hole for the purposes of inserting a wire into your hole with epoxy to make it stick, you can actually add something in the center, like a rib, an actual Let's see what size is that. Let's make that invisible by clicking the hole button. Center this, and then move it down. Let's say about here. And I'm gonna press Alt. Oops, wrong part. Right, move this down. Move it over. Kind of centered. Click this, unclick the whole thing, make it color. And then for this, I'm going to make that a hole. And for that, I'm going to make that a hole. And then I'm going to group these. Alright. So now if we stick our wire inside this hole and we apply epoxy, the epoxy will actually go into these grooves and stick much better than if you had a smooth hole, which is something that you would do, can only do, you know, with very specialized tools. Should you try to do that, you know, let's say with a CNC machine or something, you'd have to literally take a, you know, like a ball cutter and stick it down in there and then, you know, work that in there. So, I mean, to print out stuff is, you know, there's a lot of benefits over even, you know, CNC machines. But of course, you know, if you're already good at a CNC machine and you own one, then you probably don't need to worry, you know, worry about this 3D printing stuff. But that just kind of shows you some of the cool stuff you can do. And you can, like this here, this pipe, you know, it's very hard to bend brass rods and things like that. So if you're going to print one, you can, you know, get them bent as a pre-made part, or you know, find something that just like this here. You could adjust it, and then you can hollow it. And one of the things that, ooh, slowing my computer down a bit there. You can hit Alt, and then I believe, you know what? I don't remember how they did that now. There was a tutorial on hollowing stuff out, and I think what they did. Let me try this. Something like that. I can't remember what they did. Let me see. Oh, anyway, there's actually a way to hollow stuff out as well. So, yeah, what do you guys think? Would you guys use a 3D printer and use a program like this? It seems really simple for me. And I'm really bad at 3D CAD and programs that require any kind of, you know, coordinates that you had to input or anything like that. This is just, for me, it's really intuitive, kind of along the lines of something like ZBrush, you know, for sculpting, or what's the other one? Sculptress, you know. Very intuitive thing. And I believe, let me see something here. I think that you can actually import Sculptress. Let's see, what was it that you can import again? So it's SVG and STL files. Let me see if Sculptress would allow you to do that. So if you guys don't know, Sculptress is also a free 3D program for sculpting stuff. So if you ever had to sculpt something like a organic chest piece or something, let's see what I can say this as. Sculpture files only. Okay, I guess we can't. OBJ. Darn. I'm sure there's a way to convert, you know, from one file to the next, though. Well, anyways, all right. So So ice pick, what is that step you're talking about? You said it's a good multi-software format. Is that something that you use in a 3D CAD program? Is that a curiosity? Because it sounds kind of interesting, but I never tried something like that. And Ron says, my problem is that I always know the old-fashioned way of doing it immediately as opposed to learning this and ordering parts that will be delivered days later. Yeah. But for complicated stuff, I know like Nick Hilligas is always making like chest pieces for his characters that can breathe, you know. It just seems like you could make chest pieces with little hinges and print them out, and because you know it's so low cost, printing out thin pieces and as plastic from these companies. More complicated stuff like big and heavy tall stuff is expensive, but small stuff's fairly cheap. You know, and the weird thing about making armatures a lot of times is you build a really cool armature and then you cover it in either foam or rubber or plastic or silicone, and you might like your design and you might want to take elements of it for later puppets, but then you have to destroy your previous puppets. So with 3D printing, it almost allows you to repurpose stuff from your designs. You know, it's sort of like the King Kong puppets. You know, Willis O'Brien would take apart all his old puppets and reuse those parts that Marcel Delgado had to machine, and just to save time. And I'm just wondering, like, how many puppets were destroyed just for the, you know, for saving time and money. Probably a lot. And Ice Pick Method says it's one of the only ones that retains all the info on a model. Oh. Okay, so these formats, I guess somehow you lose information when you save them, huh? I didn't realize that. Yeah, step is the file type option. So I guess it's kind of like JPEG versus TIFF or something like that, or GIF files. Okay, so it was a format offered at the MCM-C site, and transferring models between programs has always been a problem. Everyone has their own proprietary formats and only want you to use theirs. Yeah. So it seems like maybe there's like an open source program out there where you can, you know, input one file and have it spit out another, because that's kind of like the old days. Remember with Real Player and QuickTime and Windows Media Player, they all were trying to fight, you know, for the format to be used on websites before YouTube came out, right? So it was like a big battle, and everybody was trying to figure out, when you do your video editing, what do you do? You know, we've got all these file types, and so there's a lot of conversion programs that came out around, you know, the late 90s to take, like, you know, Real Player format and turn it into a MP4. And Ron says Magic Sculpt and Pro Epoxy 20 is always in my shop, so the printing option always seems to get put off. Yeah, and I don't even own a printer. You know, I just find this technology, this new technology, fun to explore. You know, I mean, the things that you could do with it are really fun. It's kind of neat. And I think, you know, I kind of like the open source aspects to it, because, for example, Ron, if you have a design that you've come up with and you're like, this is, you know, you can make these little parts, and if you have enough of them, you know, these are awesome for cable controlled puppet faces, right? I mean, it probably would have been a lot simpler somehow if you had design your puppets that way, right? Like with parts which are uniform in size and shape, and um, like little levers and stuff. And I don't know. Like I think of what was the movie Corpse Bride, where they had all these sort of watch mechanisms in their heads, in those puppet heads, right? And it's such a complicated, very small space to put so many parts inside, with all these levers and pulleys and screw mechanisms and all of that. It seems like and you never see it on film, right? So it's not really like there's this, I mean, as awesome as it is, it seems like this would be such an easy way to design something like that, because I wouldn't even know where to begin with making watch parts. Like I remember when I worked at a jewelry store in St. Peters, Missouri for a long time, they had a watchmaker from Russia named, what was it? I think his name was like Yuli or something like that, like a weird Russian name. And he would actually take punches, steel punches, and take like a sheet of steel that's square, like 1 inch square, and literally punch these little teeny tiny gears by hand. He would like scribe the metal with tools, and take these punches and punch out the center large areas, and then punch out the teeth, and then punch out the center hole, and and the things worked like magic. Right? And you think that they use that like a similar technology in Corpse Bride. Very similar. If you look at the head armatures. So maybe I can quickly bring that up. I know I'm probably gonna go over tonight in time, but okay, here's something on stopmotionworks.com. Which does it really show it? Kind of does here. Maybe I can zoom in. Well, they don't really show everything, but you can see these little parts inside of his head, which are almost microscopic, because Tim Burton had these designs which are so like like a triangular head where his mouth is just a slit, and then you've got all these little paddles and expression changes. Let me go back here. Hope there's nothing crazy that'll pop up. Here we go. Alright, so here's like a little gearbox, right? They built the gearbox and all these little parts which open and close the mouth. And I guess the eyebrows, those are on just paddles, but I don't know. How do they do that? It's like magic to me. So it's tough to make conversion software because you need to reverse engineer the proprietary file formats. I never thought about that, and that's a good point. So Dave is basically saying, it's different than video technology. And Dean says this stuff is probably not targeted at someone with your skills. Yeah, because Ron can build anything just by like staring at a tabletop full of parts, and it just kind of like everything just goes together. It's like his willpower alone does it. So he says, Ron says, I just want to print high detail molds. The negative cutting that this does got me excited. But Ron, that's way expensive. I found out with that last ZBrush sculpture I did. For a 7-inch sized sculpture is like cheapest print job you can get, which is made out of like a sandstone, they call it. It's really a textured blob of material, which is not very detailed. The cheapest stuff for a 7-inch hollow piece is like $100. So any kind of puppets that are, let's say, 4 times that to make a mold, right? It's about 14 inches, because you'll have, let's say, your mold walls, virtual mold walls, and places to clamp down on and everything. So it's got to be kind of big for, you know, let's say like a 9-inch puppet, 8-inch, 9-inch puppet. Would probably be about $400. And the quality would be pretty low if you cast in it. Something that is really high quality would probably be, you know, $1,500. At least from Shapeways, using their model of I don't know, it's just way expensive. I think probably the best way to do it is to buy your own printer if you want to save money. What else? Ron says, I've thought that it would be great to be able to simulate the armature inside virtual rubber to see how the rubber will behave, because doing the redesign of a face armature takes tons of time. Yeah, that'd be kind of cool. And Dave is saying that it sounds like some of the software they would use for representing different materials, like muscles sliding over bones. Yeah, you know, there's some free software out there. There's that Unreal Engine, which you could use for free, but I don't know if it's useful. Unreal Engine, like physics, maybe. I don't know. But there are 3D ways of that. That's where, you know, I kind of am like, I get kind of, I don't want to say repulsed by trying to figure that stuff out, but that's way beyond me. Yeah, we can kind of, we can look at one of their physics, Unreal Engine physics models that somebody uploaded here, just to give you guys a clue. Let's look. Okay, it's just music. He's not talking. But yeah, there's 3D programs which this might not be physics in terms of character physics though. Even. Yeah, you know what? It's not really relevant. So anyway, I'm going to wrap the show up. Just I wanted to mention that Autodesk Tinkercad has a YouTube channel specifically for Tinkercad making products or toys or, you know, screws, probably. There's probably like a screw instruction in here. It's like, this is how you do it. It's so easy. And I guess Maker Faire and whatever else they're up to. But they have a lot of videos. And it's been around for a while, and I think the way that they're staying in business is from their sponsors. So they actually link directly to, you know, 3D printing companies, and so people, you know, print out stuff there, and then they kind of share in the revenue, and it allows them to grow. But what's cool about that, it's not a bad thing, you know, because you can get stuff for free basically and try it, and they give you some pretty awesome like coupons and stuff like that, I believe, as well. But they've got all these different tutorials. They even show you how to make a 3D printed wind-up bunny. That's awesome. If you can actually do that with gears, wow, awesome. How to make a security camera. Not sure I'd want to make one, but might have some cool stuff in there. Alright, so anyway, that does wrap up tonight's show. Thank you all for stopping by. Definitely check it out. Check out Tinkercad and see if you find it useful. And see you guys all next Wednesday. See you later.